Hi, and welcome to a live demonstration of the SIGA solutions, SIGA Guard and SIGA Insight in action using this demo kit which simulates a real live OT process. This kit has two sides. On the right is the process side, where we have a real electromechanical process which includes an air compressor sending compressed air to a pressurized tank and then moving a piston up and down. It's a simple process which simulates a typical automated industrial process. There are various sensors along the entire process, including airflow, pressure, valves position, etc. On the left side, we have the control system with all the various components of any standard ICS system, including a Siemens S7 PLC, an HMI screen, which you can see also on the bottom left, and the rest of the ICS components. Here on the bottom right, we can see the simple connectivity of the SIGA platform situated in between the sensors and the PLC, and duplicating the electrical signals directly from the source before they become data protocols. In real environments, this will be done through a SIGA box, connected seamlessly to the electrical cables, up and running within few hours of installation, work done by a local technician. Upon connection, these signals are displayed in the SIGA dashboard, which you can see on the blue screen. We will now operate the process and demonstrate a few interesting scenarios, including process anomalies and attack vectors for level 0, level 1, and level 2. Once I turn the process on, you will be able to see the electrical signals displayed in the dashboard as a live feed. The first scenario is a level 0 process anomaly that is being pre-configured by the user. You can see here how simple it is to define rules and thresholds using the Smart Alert screen. Just a few clicks and we are done. Now let's see what happens when this pre-configured anomaly occurs. The piston is going up and down, and at each position it presses a level switch. We will now manually press both level switches together, which creates a process anomaly. We will now expect the SIGA platform to detect this anomaly in real time and send an alert. As we can see here, a new alert just came in stating anomaly and piston behavior, which means that the SIGA platform was able to detect an alert about this process anomaly. This was an example of a very simple threshold-based pre-configured alert, but bear in mind that more complex rules can be easily configured, including events that coincide and occur simultaneously and involve several IOs. The second scenario simulates a cyber attack to level 1 layer, which means someone was able to infiltrate and take control of the PLC and change the set points controlling the process without any indication to the operators at the HMI level. This is a common and dangerous cyber attack for ICS networks. In this scenario, the operator is not aware of the potential occurrence of such event. Hence, he has not pre-configured it up front. The set point will be changing inside the PLC is the piston frequency. Under normal circumstances, the set point in the piston is fixed for 2 seconds. We will change that set point to 1 second only. In this case, the machine learning engine learned autonomously and automatically normal process and behavior, and it detects an abnormal behavior which the piston is moving twice as fast, an event that creates a hazardous situation for a real process. We will now return to the SIGA dashboard, where we will see how SIGA's unique machine learning algorithm is able to detect this anomaly and alert the operators that something is not right. As we can see here, a new alert just came in stating anomaly in piston frequency. Now the operator wishes to analyze the event or to perform forensics, so he easily enters the alert page to have granular visibility of the event. We can see that our algorithm was able to pinpoint the exact location of this anomaly. has its initial involvement stage and alert the operators about it. The third scenario simulates another common cyber event, a ransomware attack. In this scenario, an attacker was able to disconnect the communication between the PLC and HMI and practically blind the operators from the critical process. To demonstrate this, I will disconnect the Ethernet cable between the PLC and HMI. After a few seconds, the values in the HMI screen turn blank, meaning the operators cannot see or control the process. However, in this kind of attack, the critical process itself was not compromised and is still functioning normally. The only way operators can validate the status of the process, avoiding costly hard stoppage of the process and maintain operations, is by using SIGA Guard, which was totally unaffected by this attack and continues to visualize the process normally. This allows continuous operation and uptime until the team is able to reactivate the ICS network. In this case, SIGA enabled fast recovery, avoiding significant direct and indirect costs associated with process downtime. Thank you for your attention.